I'll start recording. Okay. Can you see my screen? Yes, no? Yeah. Okay. Okay. So let's then start. Alex, hello. Daniel. And this one is a parametric equation question. You are going to have a parametric equation question. Always there is a parametric equation question. Most of the time it's going to be including some differentiation. I would say most of them. Some of them might include integration, but it's less common. So usually it's differentiation, a normal or a tangent or something like it. And then sometimes Cartesian, sometimes no Cartesian. So we have x is this function, y is this function. In terms of the time, to find the derivative, remember to derivate Cartesian equations, Cartesian parametric equations. The best thing that you can do, unless they have asked you to find the Cartesian first, is derivate the y with respect to t. That's going to be your numerator, and derivate the x with respect to t. That's going to be your denominator. Yeah. If then you have to write it in a particular way, you will. If not, just don't even simplify. So we are derivating the y. What is the derivative of this one? Is 2 times this, 4e to the power of 2t. Remember, it doesn't change when I derivate that. Yeah. So the derivative of y is going to be 4e to the 2t, and then this 4 disappears. Derivative of x is this minus 2 multiplying the 8, so minus 16, and e to the minus 2t. So over minus 16 e to the minus 2t, we can maybe simplify the numbers, so minus 1/4, and e to the power of 2t, e to the power of minus 2t, we can write that is e to the power of, because we have the same base, we can subtract the indices. So 2t minus minus 2t is 40. Yeah, we can leave it like this. Is this okay? Yeah, we don't want to find the Cartesian unless they ask us first. And when we have the Cartesian, we could differentiate implicitly. But at this stage, because they say in terms of t, even that wouldn't work anyway. Yeah. Then point P when t is ln 2 lies on the curve, and we have to find the gradient of the curve at P. The gradient at P. We have the gradient in terms of the parameter. We have the parameter here, so straight away we can find that. Is there a mark for simplifying? Let me show you. Simplification not required. So no. Yeah. So if you simplify, it's okay. If you don't simplify, it's okay as well. They don't ask you in the simplest form, or they don't ask you in any particular form. So usually when they don't specify, they shouldn't take marks away for not simplifying. Yeah? Because you don't even know how much you want to simplify. Have we done correctly? No? Yeah. Okay, then we are going to find the gradient. So we are going to substitute t equals ln 2 in the derivative. Yeah, so the gradient is going to be minus 1/4 e to the power of 4 times ln 2. I don't know if the calculator is going to tell you this. I think it's going to give you the decimal, so you don't want to do that. Yeah. What we are going to do is 4 ln 2, and I'm going to do on the side. So 4 ln 2 using the properties of the lns, remember, is ln 2 to the power of 4. And e to the power of ln of something, e and ln cancel each other because they are inverse functions. So this is going to be minus 1/4, and then wherever my ln is, so 2 to the power of 4. 2 to the power of 4 is 16. So my gradient is minus 16 divided by 4 minus 4. That's the gradient. Yeah. Please be able to simplify these things without calculator, because calculator is going to give you decimals here. Yeah. In this case, because you get a whole number, the calculator might give you the correct answer, but if you don't get a whole number, it won't. So please get used to doing that by hand. Yeah. That's the gradient of the curve. Yeah, so that's the gradient of the tangent. Find the coordinates of P. What I'm going to do to find the coordinates of P? Who can tell me? Fraser, what I'm going to do to find the coordinates?
ln 2 into the x and the y.
Exactly. So I know the parameter, and I have two equations for x and for y in terms of the parameter. So x is going to be 8e to the power of -2 multiplied by the parameter. Sorry, let me. So I'm going to have 8e to the power of -2 times the parameter, and then -4. The parameter is ln2, and then -4. For the same reason, so the same that we did here, 2 ln2 is ln2 squared, and the minus, or even that can go as a power, so I would do as a power. Let me show you. So -2 ln2 is ln of 2 to the -2, yeah, which is ln of 1/4. Really, we can write that. E to the power of ln, again cancel, and what I have is 1/4. So this is 8 times 1/4, yeah, so all this is going to be 1/4, and then -4. So I have 8 divided by 4 is 2, -4, -2. That's the x coordinate of the point. Y coordinate, the same. I substitute. So y is going to be 2e to the 2t. So 2e to the 2 ln 2, because t is ln 2, plus 4. And again, for the same reason, this is going to be ln 2 squared, or ln 4. E and ln cancel, and I have 2 times 4 plus 4, which is what? 12. So the coordinates of point P are, the x is -2, and the y is 12. Yeah, did you get the same? -2, 12. Okay, those are the coordinates of point P. Now, next thing, it says the normal at P crosses the x-axis at point Q, and we need to find the coordinates of Q. So we have our curve doing whatever it's doing, and we have a point P, and it says the normal at P cuts at a point Q. Yeah, so that's what we really need to find, the coordinate of Q. So we really need the normal. How am I going to find the normal? Who can help me? So I need to find the equation of the normal if I want to find this point of intersection. How can I find the normal? Emily, what can I do?
Will the gradient of the normal be the negative reciprocal of the gradient we've just found?
Exactly. And what else I have?
We have the coordinates, so you could substitute them in.
Exactly. So I have the gradient of my normal line is going to be, this one is -4, so this one is going to be 1/4, negative reciprocal. And the point is this one that we found. So the equation of the line, normal, is going to be y minus the y of the point, so -12 equals the gradient, which is 1/4, x minus the x of the point, so +2. We don't need to write in any particular way. What we need to find is the point of intersection with the x-axis, that's Q. So what we're going to make is y equal to 0. So when we make y equal to 0, we have, I'm just going to multiply this 4 here. So -48 is equals to x plus 2. So x is going to be -50. Yeah. So hopefully that is, let me check the answer. Yeah, -50. Okay. And the coordinates of that point Q, because they asked me, I would recommend you to write the coordinates, not just find the x. Yeah. So the coordinates are -50, 0. Yeah. That's what they asked you. Please answer what they asked you. Is this okay? Everyone? So if you forget that these parametric equation questions, all these things, so finding the gradient, finding the coordinates, finding the straight line, cutting with the x-axis, they are all things that you have been doing for quite a while, really. Now, find the Cartesian equation in this form where k is an integer. Yeah, so we have an equation, we have a good way of checking that we are doing things correctly. We just need to find this constant. Remember, to find the Cartesian equation, what I'm going to do is to eliminate the parameter between these two. And there is always more than one way of doing it. And sometimes you find it shorter, sometimes you find it longer. Maybe the one that I do is worse than the one that you do. There is not a single recipe, yeah? So we have To eliminate the parameters, I have x is, I'm just going to copy both equations. So x is 8e to the minus 2t minus 4. So this is one equation. The other one is 2e to t, 2e to t plus 2, no? Plus 4, sorry, plus 4. I probably think the best, you don't need to make t the subject, you just need to eliminate it. So if you have e to the 2t here and e to the minus 2t here, you don't want to make t the subject taking logarithms or anything. You can substitute this whole block in the other one. Yeah, that's probably the easiest. So I can make e to the 2t the subject, which is y minus 4 divided by 2, and then substitute in the other one, for example. Or making e to the 2t here the subject as well, and make them equal to each other. That would be another way. But don't make t the subject, because that complicates your question. How I'm going to substitute e to the minus 2t? Just bringing this back to the denominator first. Yeah, I think is probably better. So your x, if I go here, your x really is 8 over e to the 2t minus 4, yeah? And then is where I can substitute this one, if that makes sense. So we want the coefficient, the exponent positive, yeah? So I have x is 8 over y minus 4 divided by 2, and then minus 4. And then it's just work a bit with the equation until it looks like the one that they gave us, yeah? So this means these two goes here. So I have x is 16 over y minus 4, and then I'm going to multiply everything by y minus 4, yeah? X brackets y minus 4 equals 16 minus 4 y minus 4. Yeah, expand brackets, xy minus 4x is 16 minus 4y plus 16. And remember, the equation that they give us is everything with x and y on the left and a number on the right that must be an integer. So that's what we're going to do. Everything to the left except the number. So we have xy minus 4x plus 4y equals to 16 plus 16. Yeah, so this is your k. K is 32. Yeah, is that okay for everyone? So Cartesian equation, we need to eliminate the parameter, but for eliminating the parameter, not always you need to make the parameter the subject. Yeah, sometimes it's a whole expression with a parameter. The same that when we have trigonometric parametric equations, we're going to use the identities. We are not necessarily, so if we have x is sine t minus 3 and y is 2 cos t plus 5, we are not going to make t the subject, saying, oh, is sine minus 1 of x plus 3. We are not doing that. We use identities. Yeah. Any question? No? More? Then next one. This one is mainly year 12 content, all this bit, so I hope you remember this well. Polynomial is this cubic here. Use the factor theorem to show that this is a factor of fx. If they don't say use the factor theorem, you could potentially divide if you don't remember the factor theorem, but if they specifically say use the factor theorem and you divide, even if that's a good way of proving that it's a factor, you can get the marks, yeah? What is the factor theorem? Tell me, can someone help me? So how I'm going to use the factor theorem here? Sarah, sorry, yeah, Alex, I will ask you the next time. What I'm going to do?
If you substitute minus 3 over 2 into the expression, then it will equal 0. And will be
and that's it. So if this is a factor of this function f of minus 3 halves, so whatever makes this bracket equal to 0 is going to be 0. So what I'm going to do, just substitute so that I show that I know what I'm doing, but I'm not going to waste time with the calculator, yeah? Because if it's a factor, I'm going to believe it, yeah? Please don't waste time substituting this in the calculator. It's going to be 0. But don't skip writing this, yeah? So using the factor theorem, because this is 0, then 2x plus 3 is a factor of this. Yeah. Now, write fx in the form 2x plus 3 multiplied by something else. Can you all tell me in the chat what I'm going to do to get this something else, please? So in the chat, what I'm going to do to get that quadratic. Exactly. I'm just going to divide. Or, as Alex said, equate coefficients. So I can multiply these expressions and then equate coefficients. That would be another way. Yeah, up to you. Inspection is the same. I'm going to divide, but as some of you are saying, you can use inspection or equating coefficients. So if I divide 4x cubed, I'm going to leave a space for the x squared so I don't get things squeezed. And then I have 4x cubed divided by 2x is 2x squared, multiply, and then plus 6x squared. I subtract, these two are gone, and then I have minus 6x squared. I divide again, so minus 3x, multiply. I have to get 0 at the end. Yeah, so if you don't get 0, it's because we have made a mistake. Minus 3 is minus 9x. So when I subtract, these two are gone, and I have minus 11 minus minus 9, which is minus 2x. When I divide, I have minus 1. When I multiply, I have minus 2x, minus 3. These two are gone, and these two are gone. Yeah. So this is that quadratic that they ask me. If you prefer, as I said, you can expand this bracket and compare coefficients or equate coefficients. A, B, and C are integers. So A, I'm just going to write them on the side. A is 2, B is minus 3, and C is minus 1. Yeah? Everyone, any question? No? Then, show that this equation can be written as 4x cubed, blah, 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 when x is sine theta. You see where this is going, no? What we are going to do is write this equation all in terms of sine. Yeah, so we have to think how we write, because this is sine and this is sine, how we write cos 2 theta in terms of sine. Remember, in your formula booklet, you have the addition formulae. So you have cos A plus B is cos cos minus sine sine. You don't have the double angle. Yeah, what you're going to do to deduce it is just write that A is equal to B, and then you have cos A, which is cos squared, sine A, yeah, minus sine squared. So this is cos of 2A. So this one is in the formula booklet. This one is not, but it's very easy to deduce. So we need to write this cos 2A to theta all in terms of sine. And I have cos squared minus sine squared. What I'm going to do? Write cos squared as 1 minus sine squared, and then we have it. Yeah, so this is 1 minus sine squared. So this is 1 minus 2 sine squared A. Yeah, that's the one that I'm going to use in my equation. So what do I have? 2 times that, but with theta. I'm going to write with theta. So 2 times 1 minus 2 sine squared theta multiplied by sine theta plus 9 sine theta. And then what else? Plus 3 equal to 0. Yeah, expand brackets, reorganize, and we are going to have that cubic. So we have 2. So if I expand these brackets, I have 2 times 1 times sine. Yeah. So 2 sine theta. Then 2 times minus 2 sine squared sine becomes minus 4 sine cubed theta, and then plus 9 sine theta plus 3, and then you see that we have it. Yeah. If we change signs, so 4 sine cubed theta, 9 plus 2, 11, so negative sine theta, and plus 3 becomes minus 3 equal to 0. Yeah, so I have changed signs of everything, so this one is positive. And then if sine theta is y, I have 4y cubed minus 11y minus 3 equal to 0. That's what they are asking me. Yeah. So the only thing that you need to remember is that this is in your formula booklet and you are able to deduce double angle for the cos or for the sine. Yeah. Is this okay? Yes. So it can be written this way. We have done that. And now it says, hence, so we are going to use this, obviously, find all solutions of the equation in this interval. Yeah. First thing you have to notice is the interval. And just double check that because we have changed this 2 theta to theta, the interval is okay. But if everything was 2 theta, please be sure that you remember to change the interval. It's not the case, so we are fine. What we are going to do is to solve this cubic. How are we going to solve this cubic? Who can help me? So how can I solve that cubic? Amelia, how can I solve that cubic? What information I have that is going to help me?
I didn't do this part, but could you just put it in the calculator and then get the values from that?
We should use what we have done already. So think that that cubic is this cubic. So what do we know about that cubic already?
We know that it goes into 2x add 3 and then what we worked out through the polynomial division.
Exactly. So we know that that cubic is the product of this one and this one. Do we know how to factorize this one?
Yeah.
It's a quadratic. So yes, exactly. So that's what we are going to do. We are going to use, and that's what they ask first, we are going to use what we just did. And I know some of you were already typing in the chat. And then 2y squared minus 3y minus 1 minus 3y minus 1. Yeah. And this one is the one that we are going to factorize. I'm going to factorize just with the calculator. But show some working out. So if you just write the roots with the calculator, you are very unlikely to get the marks. Yeah. So 2 minus 3 minus 1. The roots here. So you have the first one is y equals minus 3 halves. Then you have y equals 3 plus root 17 over 4 and y equals 3 minus root 17 over 4. Yeah. When you have to find the roots of a quadratic, let me show you the mark scheme. Use formula correctly to solve. So from here to here, I always would do with the calculator, unless it's super easy. You see the factors immediately and check what you get. If you get something like this, that means that you need the quadratic formula. So I think it's worth it, instead of writing the answers straight away, write the quadratic formula. Yeah. You write the quadratic formula and then you substitute maybe in the quadratic formula and then you put these values. But do some working out because look what they say. Use formula correctly to solve. So sometimes you don't get the answers, you don't get the marks if you don't do some working out. Yeah. Okay. So that is sine theta. Yeah. Sine theta cannot be 3 halves because it's minus 3 halves because it's between minus 1 and 1. So this one is not going to give me any solution because sine theta is between minus 1 and 1. This one is the same. So for the same reason, this one is the one that is going to give me one solution. Yeah. So if I do sine theta equals to that, sine minus 1, and then I have it. Calculator in degrees because your interval is in degrees. So please remember always to check what your calculator is in. So I get minus 16. So theta is minus 16.3 degrees. Do you get the same? Yeah. That's the principal solution or the main solution, but it's not in our interval. Yeah. So using the graph, the cast diagram, the circle, wherever you want, you need to find the other solutions. So remember, sine theta is symmetrical in the y-axis. So what we are going to do is to subtract from 180. Yeah. So we do 180 minus that, I get 196.3. They say giving your solutions to the nearest degree. So I'm going to write already to the nearest degree. So this one. And the next one is going to be 360 minus that value, yeah? Which is 343.7, so 344 degrees, yeah? Two answers between 0 and 360, and that's it, only those, yeah? Any question? No? 300, okay, that's it. Okay, then next one. Next one is this integration question, yeah? We have to find the integral of t cos something. I was going to ask, can you tell me in the chat what method I'm going to use for this one? I think parts is the easier to see, yeah? I have a product of a t and a cos. So every time I have a product of two different functions, very different, and one is not the derivative of the other, I will have to do integration by parts, yeah? So remember to use late to choose the u. So in this case, I don't have logarithm functions, but I have an algebraic function that is the p. So t is going to be my u. So I'm going to do u is t, and dv is everything else. So cos pi quarters t dt. I'm going to derive this one. So u prime is, u prime is just 1. And I'm going to integrate this one. So v is the integral of cos pi quarters of t. Who is going to tell me what this is? What is the integral of cos pi quarters dt? So think about the coefficients and all that. Daniel, tell me.
Would it go to sine and then it would be a quarter p outside and keep it the same?
Exactly. So it's going to be sine of the pi quarters t, but then I have to divide by pi quarters. I can write like this, or I can bring already my 4 here. Yeah. Remember the signs. Every time you integrate or differentiate signs, please be careful with the minuses. Yeah. So this is the integral. Remember, I don't need a constant of integration here. Now integrating by parts. And the parts formula is in the formula booklet. So remember, I have the integral of u dv is uv minus v du, yeah, in the formula booklet. So what I'm going to do now is substitute. So I have u is t, v is all that, so v is all this. So I'm going to write the 4 over pi here. I prefer it, so 4 over pi t sine pi quarters t, yeah, minus the integral of v du. So v again, and du is 1, yeah? So I have 4 over pi sine pi quarters t dt. So this is 4t over pi sine pi quarters t. Please, if someone is lost with anything, please tell me. I have this pi quarters that is going to be there. Then integral of sine is minus cos. So I'm going to change this into plus, yeah? And then it's going to be cos pi quarters t divided by pi quarters, yeah? So this, this 4 can go to the front, to the numerator. So this is going to be 16, and this pi becomes pi squared. We want to do that, so I'm going to write that already, yeah? So this is going to be pi squared and 4 squared, which is 16. You can do that in 2 steps if you prefer. And then is when I'm going to add the constant of integration. Yeah? Did you get that? The same signs and everything? Okay, perfect. So this is the first part. Now, this is a modeling question. this is going to be to help you with this. Not always the question is going to be so scaffolded. Yeah, sometimes the question is going to be this. It will be more marks, but if it's at Excel or AQA, usually is very well scaffolded. So the platform of a theme park, right, oscillates vertically. Remember, when things oscillate, sine and cos are perfect. For the first 75 seconds of the ride, dx over dt is this function here, where x is the height of the platform in meters above the ground after t seconds. So we know what x and t is. At time t0, the height of the platform is 4 meters. And we have to find the height of the platform after 45 seconds and then give the answer in a particular way. What is what I have to do in general? Then we will see how we are going to do every bit. But what do I need to find the height? You can tell me. So I have an equation with a derivative, and I need the height for a particular time. Can someone tell me what would be the idea? Fraser, what am I to do?
Differential equations, and then they're giving you the points, and you know the harder integration from the first part, and then you can find C using the points they're giving you, and then you just substitute in the time back in.
And what is that going to give me? What I'm going to be able, if I integrate this, what I'm going to have?
The constant.
The constant if I substitute this, but when I integrate, I'm going to have what function in terms of what? What is that going to help me to find the height of the platform?
Well, it's going to be in t, in terms of t.
Exactly. This is going to give me an x as a function of the time. Yeah, I will be able to find x as a function of the time. So the height of the platform for any time. So then I will substitute my 45 seconds. Yeah. If you have a question with a differential equation, 100% you're going to integrate it. Yeah. So don't even think what they're asking. Well, yeah, please read and think, but be sure that even if you don't understand very well the question or what you have to do, you are going to have to integrate that question. Okay? So let's go into integrate. And as Fraser was saying, we are going to use this. So I'm going to integrate that, and I'm going to do it in another page. Remember to integrate differential equations. I separate variables. So I'm going to write the x in one side and the t in the other. So this is my function. T cos in the numerator and 32x in the denominator, right? 32x in the denominator. So I separate variables. X all together with the 2 dx, so 32x dx on the left, and the dt together with this thing. And I'm going to integrate each side. One in x, one in t. The left one is going to be 32x squared divided by 2, so 16x squared. Yeah, I'm canceling just the coefficients. And then this one is precisely the one that we integrate before. Yeah, so this thing here. So I'm just going to copy what I have here. Yeah, you say you got the same that I did, no? Here. Don't tell me in 10 minutes that there is something wrong there. This. So that is your function. They are giving you numerical information to find the constant of integration. So this thing is not random, is to find the constant of integration. So when we know that when t is 0, x is 4. So we are going to substitute that here. So when x is 0, t is, no, the other way around. When t is 0, x is 4. When t is 0, x is 4. So I'm going to substitute that. When t is 0, so x is 4, so I'm going to have 16 times 4 squared, so 16 times 16, which is 256 on the left. And on the right, when t is 0, this is 0, cos 0 is 1, 16 over pi squared, no? 16 over pi squared plus c. So my constant of integration is this. Yeah, maybe we can simplify the number, but do we get that? Yeah, okay. So we are going to leave the constant of integration. Now, if the question asks you, write x in terms of t, or find a function of x in terms of t, then you will have to make x the subject properly. Yeah, so divide by 16, do the square root, but they don't ask us, so you don't have to. Yeah, we can substitute what we have there, and it's going to be easier to work with the numbers than to try to make x the subject. Yeah, so don't waste time for things that they're not going to give you marks. So we need to find x when t is 45. And now we have all the information. Yeah, so we need x when t is 45. What I'm going to do? Substitute the 45 and then find x after. So I'm going to have 16x squared equals 2. And then we have to substitute everything here. So I have 45 times 4, which is 180, no? Over pi. Then sine 45 quarters of pi. I don't know what that is. 45 pi divided by 4. 45 seconds. Give your answer to the nearest centimeter. Okay, so we can I'm going to substitute everything with the calculator because we don't get a nice number. I get 0.57 something. It's not like when you get 1 or 0 or yeah. So I'm going to substitute and just multiply without finding each of the terms. Yeah. So this one is 0.57 something. I'm going to multiply by 4 by 45 and divide by pi. I get 33 point something, and then I'm going to add all these things, and then I think I'm just going to give you the number in the mark scheme. Cos of pi times 45 divided by 4 divided by pi squared plus the constant of integration, and then all divided by 16 and the square root. Yeah, all divided by 16 and the square root of that, and I get 4.24. 448. Did you get that value? No, maybe not. No, you don't get that value. So I hope you get 3.65 meters. I've done something wrong substituting. Yeah, but look that the function is correct. Yeah, the constant of integration is correct. You just have to be careful with the substituting. Yeah, so you just substitute the x by the t by 45. 3.65 meters. That's what you get. They say to the nearest centimeter. So be careful because this x is in meters. So that's why at the end, the 3.64 something meters has to be changed in centimeters, and the last mark is correct solution only. So you have to give it in centimeters. Yeah, does it make sense? I don't know why I did with the calculator. It's not that. So did you get that value? Yeah. Some of you yes, some of you didn't. Okay. Any question? No? Differential equation in a question, you are going to have to integrate it. So if you understand well what you have to do at the end, please integrate. And maybe when you integrate, then you more or less know what is next. Yeah. So sometimes it's a matter of doing something that makes sense, because then sometimes the next part comes to you. Okay, next. This one is a mechanics question, very typical mechanics question. Yeah. Mostly, I would say for Edexcel. So this question, the same type of working out in AQA, it will be a rod on a couple of supports, not that much a ladder. So ladders are more typical in Edexcel papers, but in AQA you will have a rod against the ground and a peg or something. So you're doing exactly the same. So you have a ladder, length 5 meters. So this is the ladder, mass 18 kilograms. Has one end A resting on rough horizontal ground. So the ground is rough. We are going to have some friction on the ground. The other end be resting against smooth vertical wall, very typical, only friction in one. And then the ladder lies in a vertical plane, angle alpha, tan alpha is 4/3. So remember this triangle, if alpha is 4/3, if tan alpha is 4/3, opposite 4, adjacent 3, with Pythagoras, this is 5, so we know sine and cos. Coefficient of friction is mu, and then we have a woman of mass 60 kilograms standing on the ladder at point C. AC is 3, and the ladder is on the point of sleeping. Is modeled as an uniform rod, yeah? So with all this information, my recommendation is the first thing you do is to draw all the forces acting here. Yes? So at A, can someone tell me? Can someone help me to draw the forces? What I'm going to draw? Let me face it. What would you?
So you're going to have the normal reaction force at the wall pointing to the left.
Which is to the left, exactly. I'm going to call it, I don't know, RB.
Yeah, and then you're going to have RF at the floor pointing directly up.
Exactly. I'm going to have another normal reaction here. What else?
You're going to have friction at the bottom moving to the left.
To the left, the friction, or to the right?
It's slipping down, isn't it? So it moves. Oh, no, sorry, to the right. Yeah, sorry.
To the right is on the point of sleeping, which, what does that mean, this? Any of you? What does that mean? Emily, what does that mean?
That the friction is maximum.
Exactly. So friction is maximum. So I can say that this is mu r, and that's going to happen in all the questions, right? So Fraser, you were saying that this is to the right because it's on the point of sleeping, and if this slips, it will slip to the left. Yeah.
Yeah.
Two more forces. What else?
At 2.5 meters, you've got 18 G pointing down. And then at 3 meters, you've got 60 G.
Exactly, that's it. So I have the mass of the woman at C, so 60 G, and in the middle, because we are modeling this as an uniform rod, I'm going to have the mass of the ladder multiplied by G. These are all my forces. Yeah. Now, find the value of mu. So very, very typical question. Yeah. To find the value of mu, because I have an equation that links RA and F, the friction and the normal reaction with mu, at the end, what I have to do is to find friction and normal reaction, yeah, and substitute here. And remember, this is in equilibrium, and I have two things that I can apply. So sum of forces in any direction is 0, resultant moment about any point is 0. And because this is a moment question, I will need to apply moments for sure. But everything else that can be solved just with forces is always going to be easier. Yeah, always forces is easier because I don't have the distances, but you're going to have to apply moments. So then let's think. We have, very quickly, we know that this normal reaction, if I apply forces, is equal to these two. Yeah. So if I resolve forces vertically, the force pointing up is going to be equal to the two forces pointing down. So I can find this one immediately. Now I have to find this one. Let's do first. Let's do step by step instead of seeing the whole question. So if I resolve vertically, because I have equilibrium, my force pointing up, the only one, is going to be equal to my two forces pointing down. So 60G plus 18G, that R is 78G newtons. Yeah, I can leave it like this for now. Now, if I resolve horizontally, it would be amazing if I could find my friction, but I don't have this one either. Yeah, so I know these two are equal to each other, but nothing else. So I will have to take moments. Now, you can take moments about any point. My recommendation is that you take moments about A. You can take moments about any other point, but if you take moments about A, I know you will say, friction is not in my equation, and it's precisely the one that I want to find. Fine. But you know the friction is going to be equal to RB. So if we find RB, we already know the friction. And if we take moments about A, our equation is going to be slightly simpler because I'm removing two forces out of my equation. Yeah. So if I take moments about A, this one and this one won't be in the equation. Does it make sense? If you take moments about any other point, you will get the same answer. Just the question will be slightly longer, and it doesn't matter if you are careful. When you take moments, please say where you are taking moments about. I always tell you, say the point, because for someone marking, if you don't say the point, sometimes it's very confusing. If you make a mistake with the distances or something, we don't know what you are taking moments about, honestly. So just say moments about A is 0, and then it's going to make person marking easier. Person's making lives easier. So moment about A is 0. Let's do it. So about A, this force is producing a clockwise moment. This force is producing a clockwise moment, and this force is producing an anti-clockwise moment. Yeah? So the two clock are going to be equal to the anti-clock if this is in equilibrium. So I need to multiply the force by the perpendicular distance from the point to the line of the force. So this is the line of the force, right? So perpendicular distance is this one. So perpendicular, here is perpendicular from the point to the line of the force. This distance, if I look at this right angle triangle, is adjacent to the angle, and I know the hypotenuse. So the hypotenuse is 2.5. Remember, this is the midpoint of the thing. So this is 2.5 cos, because it's adjacent, alpha. Yeah? So this one is going to be 18g times 2.5 cos alpha. And then we will see what is cos alpha. Who can tell me the next one? So this one, 60g. Fraser.
Is it 3 sine alpha?
It's again the adjacent. So
Oh,
this
so
is
cos.
cos, exactly. So this, the hypotenuse is 3, and again is the adjacent. So it's going to be 3 cos. This distance is 3 cos, and multiplied by 60g. So 60g multiplied by 3 cos alpha. And now that is going to be equal to the anti-clockwise moment produced by this one. I would like you to try to tell me in the chat, what is this moment? So the moment of this force. Don't tell me the value or anything, just RB multiplied by what? 3 sine, 3 cos, 5 sine, 5 cos. So what? RB 5 sine alpha, RB 5 cos sine. Okay, if you are writing cos, it can be cos, but of another angle. So be careful, because we don't know the angle, we know sine, cos, and tan. So let me show you. This is the line of the force. And remember, I'm going to do a perpendicular line from the point I'm taking moments to the line of the force. This one is perpendicular, yeah? So I'm really looking at this right angle triangle and trying to find this distance. This is 5. This is 5. And this is the adjacent to this angle, but I don't have this angle, I have this angle. And this length is the same as this length. And this length is opposite to the angle. So it's sine alpha. If you have the angle, you can find this one, and then it will be cos. Yeah, so it depends on what you want to use, but really we are trying to find this distance here. Yeah, so this is the one that we are trying to find. So this distance is the same as this distance, and this distance is 5 sine alpha. Emily, you wrote cos, I think, but you were thinking about this angle here, right? No? So you were trying to give me this angle, this side. Okay, but you see why I'm using this one? Is perpendicular from the point to the line of the force is this distance here. So be careful once we have the right angle triangle of choosing the correct length. Yeah. So it's going to be RB times 5 sine alpha. Yeah. Let me just carry on in the next page. So from here, I have sine, I have cos, I have everything. So I have 18g times 2.5 cos alpha is adjacent divided by hypotenuse of 3/5 plus 60g times 3 cos alpha again, so 3/5 equals RB times 5 sine alpha is 4/5. From here we can find RB very quickly. Yeah, so calculator, we find this, divide by 4 because the 5 cancels, and we have RB. I'm going to give you RB. RB, they call it R. So R is 135 over 4G. 135 over 4G. That is RB. You can multiply the G or not. It's really up to you. Yeah. And from here, we know that RA is 78G. We have RB. So somehow you have to explain that RB, and I'm going to clean now all the mess. RB is the same that RA. Yeah. So please remember that we are writing. So RB is the friction. That's what we are doing. Yeah. So if we still have to resolve horizontally and say that RB is the friction, so the friction then is 135 G over 4. And when we say that the friction is mu normal reaction, we have the friction is 135 G over 4 is mu normal reaction that we saw is 78 G. 78 G. Yeah. So mu from here, we can cancel G. And we have 135 divided by 4 and divided by 78. And that's your mu. Yeah. If you get something greater than 1, please don't get scared. Doesn't need to be wrong. We think that it has to be smaller than 1, but it doesn't. So this is 0.43. Yeah. Very typical, very typical. We don't have friction here. We have friction here. We are taking moments, probably just once, and then everything else can be sorted out with resolving forces. But I think what you find most confusing is to find the distances. Yeah. So then just try to think what is the line of the force and do a perpendicular line from the point to the line of the force. So perpendicular, and that's the distance that you're trying to find. Yeah. Every time. Line of the force, perpendicular. Line of the force, perpendicular. Yeah. Working, which working? This one? Okay. Is that it? Did you get 0.43? Yeah, okay. And then the last one is that okay? Is enough to work it out? Okay. Last one is this one. This one is a bit not strange, but this is one of those questions that you don't want to see because sometimes we don't know what to do with them. So we have, because when you start reading, you think, this is a tree diagram question. They're going to start getting coins here and there, and it's not necessarily that. So we have a bag with a large number of 1p, 2p, and 5p coins. They give us the percentage. And we have a random sample of 3 coins. Yeah. They say it's a large number because every time you get something from a bag, if it's a large number, the probability won't change. But imagine you have only 6 coins and the first 2 are 2p coins. Then you will have less 2p coins and the probability will be less. But if you have a large number, the probabilities won't change. That's what you want. That's what they say. So we get 3 coins. List all the possible samples of size 3 with median 5. So all the possible samples of size 3 with median 5. Can you tell me in the chat? Because there are not too many. So can you tell me the options in the chat? So all the possible samples of size 3 with median 5. So I need 3 coins each time. And the median must be 5. Exactly. Everyone else see that? So I have 3 coins. 3 coins every time. The median is 5. and I have always my coins in order. So if the middle number is 5, this one has to be 5 because I don't have any other options. And this one could be 1, could be 2, or could be 5. Yeah? So that's why. So my options are going to be 155, 255, and 555. So these three, the median is 5. Yeah? Remember what the median is? And it's just when I have my numbers in order, the middle one. So these are my options. Yeah? Nothing else. So sometimes it's just a bit of thinking, not even probability maths, it's just more logic. Now, find the probability that the median is 5. So what do we need to find? The probability of each of these options. Yeah? And then we will see what we do with them. What is the probability of getting 155? Or let's start with this one, 555. 555 is here. So probability of getting 555. How am I going to find that probability? Daniel, tell me.
Would it be 0.3 cubed?
Exactly. Or I would write 1/3, just in case. So 30% of the coins are 5p. So it's 1/3, 1/3, 1/3. So the first coin of 5 and the second of 5 and the second of 5. Every time I say and, I multiply. Yeah. So it's 1/3 cubed or 1/3 cubed. It doesn't matter how you write it. Now, what about the other two? Because they are slightly different. So 255. What is this probability? This is not the same. Does anyone know what this probability is? This probability is going to be the probability of having 2 5s. So 5 and 5 and a 2. The probability of a 2 is 20/100, yeah, or 1/5. No, 20/100 is 1/5 or 1/5. Yeah, but why 1/3? Because 0.3. 300 is 30/100, no? 30% is over 100. Yeah, it's 0.3. I don't know why I wrote 0.3. 1/3. It's not 1/3. Sorry, you are completely fine. Sorry, it's 0.3 to the power of 3. Thank you, Svara. 0.3. I don't know why I was thinking it was 1/3. It's 0.3. And then the other one is 20%. 20% is 2 out of 10, which is 0.2. No, I don't know what I was doing. So is that it? Oh, no, look. 3/10. Yeah, 3/10, which is 0.3. Yeah, sorry. I was thinking 0.3. 3, okay, forgive me. Now, 5 and 5 is 0.3 times 0.3. And then 2, the probability of getting 2 is 2 out of 10 or 0.2. Yeah, so the probability of 5p coin is 0.3. Probability of this one is 0.2. Probability of this one is 0.5. What else I have here? I have more than one combination here. So I can have 255, 525, 552. So when my numbers are different, I have to consider that the order will change. Yeah, so 255, 525, or 552 are different options to give me that probability. So my probability is this one. In the last one, 155, I have exactly the same. So I have 2 5s and 1 1 that was 0.5. And again, 3 options for that. Yeah, 155, 515, 551. It's like when you do those questions that are a head and a tail, and then you consider all the options changing the order. Yeah. Then this is the probability of getting 555, 255, 155. But what is the probability that the median is 5? What am I going to do with these probabilities? Can someone tell me? Emily?
Add them all together.
add them all together because it's having 555 or 255 or 155. Yeah. So I'm going to just add them all together, and you get 0.216 or 27 over 125. So 27 over 125. Yeah, that's the probability of median 5. And the last bit, it says, find the sampling distribution of the median of samples of size 5. So they are asking you the table. Remember, we have done that table before, where in the top arrow, in the top row, I'm going to have my options, my median, and then in the bottom, I'm going to have the probability that the median is wherever that is. Yeah. What can be my median with these numbers? Can be 1, 2, or 5. Yeah, 1, 2, or 5. And I need the probability of those. So I know the probability of median 5 is 27 over 125. I have that one, which means I can find the same with the others. What is the probability of the median being 1? And you tell me what options I have, the same that we did here, for the median to be 1. So what are the options for the median to be 1? So what are the combinations? Like here, 111, 112, 115. Exactly. Those are my options. So what I'm going to do is the same that I did here. Find each probability, add them together. So I'm going to do the ones. Probability of 1, 1, 1. It was 0.5 cubed. Yeah, 0.5. Probability of 1, 1, 1, 1, 2 is 3 times, because again, the 2 can be in 3 different places, 0.5 squared, and then a 2 was 0.2. And probability of 1, 1, 5 is 3 times because of the 3 options, the 1 squared, and then the probability of 5 was 0.3. And I am going to add them all together. Yeah? For the last one, and that will be this one. For the last one, we can see the options. The options would be 1, 2, 2, 1, 2, 5, 2, 2, 5, 2, 2, 2, and add them together, or do 1 minus these 2 together. Yeah, because they must add up to 1, so it's up to you. You can, again, check the options, or just do 1 minus these 2. I'm just going to give you the numbers to not keep you longer. Yeah, so this one is the one that we found before. Then this one, the option for 1 is what we just found, that is 0.5, and the option for 2 are all these options, that is 0.84. Yeah, so 0.5, 0.284, 0.216. Is this okay? Some of you say at the beginning that this one was the difficult one, no? It's a bit strange. You have to think. I think this is one that many of you will suddenly think, what are they telling me? Please think about the options. So sometimes these questions, or when they give you 2 probability distributions and they ask, find the probability that x is equal to 2y or something like this. Sometimes it's just thinking about the possible options and then just find the probabilities once you know the options. Yeah. Okay. That's it. Do you have any question? No? Fraser, tell me.
You know, because they're making you do a distribution, sampling distribution, could you have treated it as one of them to begin with, or not?
What do you mean one of them to begin with? What do you mean?
You know, if you had like discrete random variables, you often use a sampling distribution. Could you have treated it like that or not?
But like which one? This is a discrete distribution.
Yeah, but like in part A, could you have worked out
In part A,
or not?
list all the possible values of sample with median P. I don't think so.
I was just wondering, because when I first read the question, that's what I thought, but I didn't really know. So I was just asking, is that because of how they presented the data? But
I don't know if have you done that or
No, I didn't know how to do it. I was just asking that. That's what I'm saying.
no?
That
I don't think so. I cannot see how you can do that with this one. If that makes sense. Yeah. Okay, more questions? No? Okay, then I see some of you in 20 minutes and some of you next week. Bye-bye. Enjoy the rest of the weekend if I don't see you.
Thank you.
Bye.
Okay.
Thank you.